This is going to be the final part. We are going to use our explanation to fill in the table. And after filling the table, we are going to graph or to plot our function. Okay. We are going to use our explanation here so we can fill in the table, as I said before. So we are going to use 4 steps first. We can do it like a plot it on spot. No need for using the table for the 4 steps. First of all, I have to say vertical asymptotes equals x equals -2 and x equals 2. We are going to use it to draw the lines vertically, like this way. Is it clear? Okay. I don't have a big ruler, so we're going to use the points of x equals 2 and -2. So we are graphing our vertical lines passing through the point on the x-axis, which equals to 2, like this way. Okay. Another vertical asymptotes, x equals -2. Okay. Let's draw another one, passing the point x equals -2 on the x-axis as a vertical asymptote. Okay. Passing through the point -2. We have another line to graph actually, which is the horizontal asymptotes, y equals to 2. So we are going to graph another line, y equals to 2. Like this way. You know, the graph is dividing our sketch to apart, so you can figure from the intervals which quad you are going to work with. So, like this way. Okay. Now, if you can take a deep look for the graph, you are going to find that we have each point. You are going to use part 3 and 4 right now, so you can determine which part you are going to plot in a graph. So, for part 3 and 4, you are going to plot the points of the x-intercepts and the y-intercepts. So we have x equals -3 and x equals to 3. So this point, I don't know if it's clear or not. X equals -3. Right now I'm plotting the points of the x-intercepts, and we have another one, y-intercepts, when x equals to 0, y equals to 4.5. So we are going also to plot the point 4.5. So already we used all the steps 1, 2, 3, 4 to start to draw dashed lines and to determine which part we're going to use to graph. Right now I'm going to start to fill in the table. And how can we fill in the table? Okay. We have round 1, 2, 3, 4, 5, 6, 7. 7 intervals. Starting with the first one, -infinity to -2. This is going to be the first part starting from -infinity, reaching the 2, or the -2, I'm sorry. And we have a critical point which is undefined for the point x equals -2. So, let's start with the first one. How can we get the value of negative here and negative here? Okay, what you have to do to plug in a value in between -infinity and -2, let's say -3. Plug in the value for -3 in each of the function, this one, and -3 also here. You will get what? You will get the negative sign. Let's make it. If you are going to plug -3, the number in between -infinity and -2 here, so Negative 3 times 20 equals what? Negative 60, right? And for this part, it's going to equal to positive. So negative divided by positive equals negative. So we are going to plug in the sign here. What about if you are going to take the other one, the other function, which is the second differentiation here? Plug in the negative 3 here. Negative times negative equals to what? To negative outside. And this one is going to equal to what? To positive. So negative times positive equals negative. Negative divided by positive equals negative. So in this case, as I told you before here, for the second part, okay, which is the first differentiation, is telling us if it's increasing or decreasing if we have maximum or minimum relativity. Okay, so let's go here. As we told you before, if it's positive, it's going to be increasing, and if it's negative, it's going to equal to what? To decreasing. Okay, so this one is decreasing, and the other part, or the sign here, if it is negative, as I told you before, concave down. So this sign is negative, so I'm going to write concave down. Okay, what about the case of the vertical asymptotes, x equals negative 2? As I told you before here, vertical asymptotes, we have 2 points undefined, okay, negative 2 and 2. So all this term, or all this row, is going to be undefined. So this one is vertical asymptotes. Do we have another one? Yeah, we have x equals 2. Which is vertical asymptotes also. Okay, what about the interval in between negative 2 and 0? Negative 2 and 0. Negative 2 and 0. The same way, what is the number in between negative 2 and 0? Negative 1. Plug in the value of negative 1 here and here. Okay? You will get negative and the other one positive. So, for this negative sign, decreasing. And for the positive means concave up or down? Up. Okay. As I told you before, also from our explanation, when x equals 0, y equals to what? 4.5. So 4.5. If I'm going to plug in 0, this function, you're going to equal to what? To 0. If you're going to plug in the value of x equals to 0 in our second differentiation equation, our signs are going to be equal to plus. So in this case, actually, or especially in this case, if we got 0, as I told you here, from the first differentiation, if you got 0, this means what? Maximum or minimum, okay? So for the 0, you can figure that we have a relativity, but we cannot determine if it's maximum or minimum. We can define this, if it's maximum or minimum, from the plus or the negative sign. If it's maximum, okay, the sign is going to be here negative. If it's minimum, the sign here is going to be positive. So this one is positive means what? The relativity is minimum, not maximum. Okay? So the condition for the 0 in the first differentiation means you have relativity. If it is going to be local minimum or local maximum, it depends. If the sign is positive in the second differentiation, it's going to be equal to minimum, okay? And if it's negative, it's going to equal to maximum. Okay, for this row, if you're going to plug in the value of 1 in the first differentiation, you're going to get 0 plus, I'm sorry. If you're going to plug in the 1 here, in the second differentiation part, you're going to get plus in the signs. This means increasing for the first plus. And concave up because it's plus. Okay, the last one, if you're going to plug in, for example, 3 positive, you're going to get plus, and you're going to get here minus, which means increasing, concave down. Right now we can graph, right or not? Okay, we can graph Actually, you got a table right now and you have to graph it. What we're going to do right now, we're going to graph it. Starting with the first interval, we have the first interval, right? Okay. From negative infinity to negative 2, we're going to graph our plot here. So it's concave down and decreasing. So the function is going to decrease and concave down. Concave down, it's going to be like this way. Concave down, the graph should be like this. This is the meaning of concave down. Concave up should be like this. So the face of the function is going to be up, means concave up. And concave down, the function is going down. Okay. We're going to graph right now the interval negative infinity to negative 2. Like this way. I'm not quite sure. Okay. This is great. Okay. What about this interval, negative 2 to 0? It's going to be in this interval, right? So we're going to graph it like this way. And the third one, from 0 to 2, increase and concave up. So we're going to be increasing like this way and going up. Is it clear right now? Okay. The final one, or the last one, from 2 to infinity, increasing and concave down. It's going to be like this way, concave down and increasing. So we have to graph it from down to up. Okay, I prefer to do it like this way. Okay, so this is the graph table and explanation for each part in the question. Thank you very much.